Hi, this is Dr. Green, and I wanted to go over a example for the final exam for you here. So they did a really good job with the ANOVA in the video that was on Blackboard, but they didn't tell the whole story. So let me help you work through an example that's very similar to the one that you need to do. So here we're given some information about GPAs for freshmen, sophomore, junior, and seniors. And the question to answer here is determine if there's a difference between the GPA for the different classes. So what I did here was I graphed the data here, 16 data points here. So we have the freshmen, the sophomores, juniors, and seniors, and we want to know, is there a difference? Well, between freshmen and sophomore, just looking at the data here and seeing how they're spread out, it looks like these guys are pretty close to the same. Looks like the juniors maybe did a little bit better and the seniors did worse. So how do we determine if there is a statistically significant difference? Well, you're going to run an ANOVA and you're going to compare the means from these different samples to try and test if they came from different populations. So in running our ANOVA, our null hypothesis is that all the means are equal, that is all the population means. Our alternative hypothesis is that at least two of those means differ, but it doesn't tell us which ones. And that's why I wanted to do this example for you, because there's some tests that you have to do after the ANOVA to tell which ones differ. So I am going to go to the Data tab here and go to Data Analysis. I'm going to do a single factor ANOVA right up at the top. Click OK. My input range, just going to drag over the data here. Make sure that my labels in first row is selected. Make sure you select the labels when you do that, otherwise it'll mess up. And I'm going to do an output range here and put my upper left corner of the table right there and click OK. So let's take a look at our ANOVA here. So we can see here that, bring this up a little bit. So we can see here that our mean GPA for freshmen was 2.6, for sophomores 2.625, so those are pretty close. They're probably not statistically different, but the juniors were up at 3.25. So that makes me think that they're better, that they did the best, and the seniors down at 1.95, I think maybe they did the worst. So what's important out of the ANOVA? Well, we look at our p-value here. I'm going to put that in bold, and that p-value of 0.0096, that's really a lot less than 0.05. So that is statistically significant. We're going to reject the null hypothesis that all the means are equal, and we're going to conclude that at least two means are not equal. So I'm going to state my conclusion here. We're going to reject H0, that's the statistical conclusion. Statistical significance, and then the practical significance is that at least two of the means differ. However, we don't know which ones. We just know at least two of those differ. We have an idea. So what we're going to do is we're going to carry out t-tests with pairs of these samples to try and decide who did better. So it looks like the freshmen and the sophomores were pretty close to being the same. So question mark, are sophomores and freshmen the same? Well, I did a two-sample t-test independent, assuming equal variances here. My null hypothesis was that the freshman GPA was equal to the sophomore, and my alternative was that the freshman GPA was not equal to the sophomore. So I ran that t-test, and again, what I did there was I just went up to data, I did data analysis, and then I wanted a t-test two-sample assuming equal variances. Clicked OK. For my range for variable 1, I did freshmen. And for my range for variable 2, I did the sophomores. Hypothesized mean difference is 0. Clicked labels for the first row because I did select the labels. And then I clicked my output range. And then I just clicked right in here, or actually right there, and I ran my two-sample. So when I did that, my two-tailed p-value here was 0.94. That's a lot greater than 0.05. So our statistical conclusion here is that we do not reject the null hypothesis. That means that freshmen and sophomores are not statistically different. Okay, so they're the same statistically. That's our practical conclusion. So what we're seeing up here is that freshmen and sophomores look like they're pretty close. They are close. They're not statistically different. So now let's see if the juniors did the best. So we can compare them to either the freshmen or the sophomores and show that juniors did better by looking at a one-sided p-value. So I did that in the second t-test. So did juniors do better than sophomores? I compared them to sophomores. My null is that junior and sophomores were equal. My alternative is that juniors did better than sophomores. So the junior GPA was greater than sophomores. So I ran my t-test here, and I got a one-tailed p-value here of 0.0476, which is less than 0.05. So I reject the null hypothesis, conclude that the juniors did better than sophomores. So that means that juniors did the best out of everyone. And that's what we're seeing in the graph up here, is that juniors scored highest in GPA. And now we want to show that seniors did the worst. So we could compare seniors, going back here, we could compare seniors to either sophomores or freshmen, either way, because these are statistically the same. So if we showed seniors did worse than one of those, then they did worse than everybody. And so I ran another t-test. I compared seniors and freshmen. My p-value here was 0.035, which is less than 0.05. So my null hypothesis was seniors equal freshmen in GPA. I'm going to reject that and conclude that seniors did less than freshmen. Again, because the senior mean was less than the freshman mean. So here we would say that we're going to reject H0. And what that means is that, yes, the seniors did worse. The seniors were, in fact, less than freshmen in GPA. So now we know what happened here. We know that, just like on the graph here, seniors did the worst because they did worse than both of the freshman and sophomore. Juniors did the best because they did better than freshman and sophomore. And freshman and sophomore were not statistically different. So you want to do something very similar in your problem. The graph can give you an idea of what to do, or you can run the ANOVA and look at your means and try and decide from your means. You're not required to do the graph. Now, when you get done with all your t-tests here, you are going to do a write-up, and you want to do an APA write-up here. And that APA write-up will look like this. So we did a one-way ANOVA test to determine if there was a significant difference in GPA between the classes. Results of the test indicated that there was a statistically significant difference. That was our alternative hypothesis. The F value for 3 degrees of freedom and 15 degrees of freedom was 6.02. So let me show you where I'm getting that. So go back to our ANOVA. 3 degrees of freedom are here. That's degrees of freedom. Let's see, I believe that's between. Yes, between groups, degrees of freedom. And then 15 is the total. And there's the F value of 6.02. And then our p-value was less than 0.01. We want to include that. P was 0.009, less than 0.01, certainly less than 0.05. And that meant that at least two means were not equal to each other. That was our alternative hypothesis. Our post hoc tests, post hoc t-tests, so that's what those extra t-tests are called to try and decide, which things are equal and not equal, showed that juniors had the highest GPA, and the t-value there was 1.98 with 6 degrees of freedom. P was less than 0.005. And again, that was juniors did the best here. Right here's your 6 degrees of freedom. There's your t statistic of 1.98. And that's our 1.98 there. Our p-value was less than 0.05, right here, 0.0476. And then also seniors had the lowest GPA here. And the t-value, I was looking in the same places, the t-value there was negative 2.2 because seniors were lower than, let's see, we compared seniors to freshmen. Seniors were lower than freshmen. There's my t-value, negative 2.20. My p-value was less than 0.05. And we would want to add on the end here that sophomores and freshmen were not statistically different. So, and sophomores and freshmen were not statistically different. And we would just need to say there p is greater than 0.05. When things are statistically different in APA format, you don't usually state the t-value also. So, and then this is the formal interpretation. You will want to include that in your final write-up of results. And you'd like to write a paragraph or two summary that's going to introduce your experiment, talk about the purpose, check the rubric, and then, address all the questions in complete sentences explaining, what things mean, statistical as well as practical significance. So, for example, statistical significance here was f of 315 was 6.02, p less than 0.01. The practical significance there was that at least two of the means are not equal to each other. So at least two of the GPAs are not equal. So what does it mean in real life? And then don't forget your faith component. Also include that at the end of your paper. It doesn't have to be long. Just try to make a connection with Christian worldview. Remember, we're handling snakes here. We're trying to help people overcome their fears. So you could distribute portions of your essay before and after Excel if you want, Excel results in the Excel document, or you can do a write-up as a Word document. Either way is fine for me. But remember to check that rubric and make sure you're satisfying all the requirements. All right, hope this helps you.